We're going to be taking a look at problems 3 and 4 on the Projectiles Launched at Angles worksheet. Number 3, a golf ball is hit with a velocity of 24.5 meters per second. That's the hypotenuse of our velocity triangle here. And it's hit at 35 degrees above the horizontal. So 35 degrees is the angle in the bottom left corner. What is the range of the ball, meaning how far does it travel in the x direction before it gets back to the ground? And what is the maximum height attained by the ball? So we'd be looking for the position right here at the top of the path. First thing we have to do is find the velocity in the x and the velocity in the y. To find the velocity in the x, that's the adjacent side of our triangle, so I would use the cosine of 35 degrees times the hypotenuse, which is 24.5. Plugging that in my calculator, I know the velocity in the x direction of this projectile is 20.1 meters per second. Velocity in the y direction is the opposite side of this triangle. So that means I'm going to be using the sine. So sine of the angle 35 degrees times the hypotenuse 24.5 gets me an initial velocity of 14.1 meters per second. If I solve for maximum height first, we could solve for range or maximum height. Doesn't matter which, but we will have to do them separately. If I solve for maximum height first, my velocity in the x is 20.1. My initial velocity is 14.1. I just found both of those. My final velocity in the y is 0 at the maximum height, and the acceleration, as always, is negative 9.8 meters per second squared. We're looking for d, so I can actually solve for that one right away. I don't need time to do it. I have 3 numbers, so I'm going to use that fourth equation, vf squared equals v naught squared plus 2ad. I would subtract v naught squared over to the left side and then divide by 2a to get d all by itself. I would plug in my numbers. Vf is 0, v naught is 14.1, acceleration is negative 9.8. And once I plug all those numbers into my calculator, I will find that the maximum height is 10.1 meters. The range position, or how far it's going to go in the x direction, is the question mark. Velocity in the x direction is 20.1 meters per second. The displacement in the y is 0 because it started on the ground and it's landing back on the ground. So the height change is nothing from the beginning shot to when it lands. The initial velocity in the y is what we already solved for at the beginning of the problem up here, 14.1 meters per second. Acceleration, negative 9.8 meters per second squared. Again, we're going to be using the third equation to solve for time in the y direction. So using only our y numbers, we're going to be able to solve for time. D equals v naught t plus 1/2 at squared when we rearrange it for time. Again, displacement is 0 meters, much like it was in the second problem on this same packet. So I could plug in 0 here for d and then not have to use the quadratic formula, but we're going to have to use the quadratic formula on times where d is not 0, and those are coming. So I want to make sure that you've seen it as much as possible. So the equation time equals negative v naught plus or minus square root of v naught squared plus 2ad all over a is going to be this third equation rearranged for time every time we want to use it. So if you're not familiar with it, if you're not sure what it is, please write it down on your equation sheet. It'll make your life easier. We're going to plug in our numbers where v naught is. We know that's 14.1 meters per second. There's the plus or minus 14.1 meters per second. That gets squared. Plus 2 times the acceleration of negative 9.8 times d, which is 0. All that is divided by negative 9.8, and that tells us our time is 0 seconds or 2.9 seconds. Well, we know the golf ball is not going to get from when it's hit to when it lands in no time at all. So 2.9 seconds has to be the time that we use. Looking in our x direction, we have constant velocity motion, so d equals v times t. We know velocity is 20.1, that's right here. And we know time is 2.9, that's right there. So d equals velocity multiplied by time. Plug that into your calculator, and you'll find a range position of 58.3 meters. For number 4. A Governor Mifflin soccer player kicks a ball that is on the ground across the field with a velocity of 14 meters per second at an angle of 20 degrees above the horizontal. So our hypotenuse would be 14 meters per second, and the angle in the bottom left corner would be 28 degrees. A teammate heads the ball into the goal. The teammate's head is 2 meters above the ground. So you can see here's one possible spot for the teammate. Here's another possible spot for the teammate, depending on if they head the ball while it's on its way up or head the ball while it's on its way down. The problem does not specify. How far away are the two players from one another? So basically, we're looking for the displacement in the x from the person who's kicking the ball to one of these two people. There are two possible answers to this one. First thing we need to do is find the velocity in the x direction. That's the adjacent side. So we're going to use cosine. Velocity in the x equals cosine of 28 times the hypotenuse velocity, which is 14. So velocity in the x is 12.4 meters per second. And we plug that in right here. Velocity in the y direction is the opposite side of this triangle. So we're going to be using sine, which is sine of 28 times 14 meters per second. That's our hypotenuse. And that's going to equal 6.6 meters per second. So there's our initial velocity in the y. We're looking for this x distance, but we don't have enough information to solve right away. We would need the time first. So we're going to solve for time in the x and then, or in the y, and then use it in the x to get the displacement. To solve for time in the y direction, we're going to use the third equation, the d equals v naught t plus 1/2 at squared. To do that, we will need to use the quadratic because d and v naught and a are all numbers that aren't 0. So using that quadratic formula equation for time again, if you aren't aware of what this is, write it down on your equation sheet. It will help you. So time equals negative v naught plus or minus square root of v naught squared plus 2ad all over a. Plugging in my numbers, v naught is negative 6.6 meters per second. Then again, plus or minus square root of v naught, 6.6 meters per second, squared plus 2 times the acceleration of negative 9.8 times d, which is 2 meters, all over a, which is negative 9.8. Plug all that into my calculator, and I find that the ball will get to a height of 2 meters, either at 0.46 or 0.89 seconds. The 0.46 is the first time it reaches 2 meters, which is when it's on its way up and would get to this person. At 0.89 is when it's gone up past that first person and comes down to the second person in a total of 0.89 seconds. Both times are possible. It just depends on if you're heading the ball on the way up, 0.46 seconds, or on the way down, 0.89 seconds. So we'll solve for both. While it's rising, 0.46 seconds, multiply that by the x velocity because d equals v times t. And we know that this first player would be 5.7 meters away from the ball when it's kicked. If I do that again when it's falling using the 0.89 seconds, d equals v times t, velocity is still 12.4, time 0.89, multiply them together for a displacement of 11 meters. So this player here, if this is when they had the ball, is 11 meters away from the ball when it's kicked.